Hey guys, for our next lesson, we are going to talk about compound interest. Compound interest is earned on both the principal amount, and your principal amount is the initial amount that you deposit, and any previously accumulated interest. Every time that it is compounded, I'm getting interest paid off everything that I have up to that point. So, my initial plus anything I've gained up to that point, I earn money on. And then the next time, my initial amount plus whatever I've earned, I get money on. This is our favorite. Like if we are going to invest money, we want to invest in a compound interest situation. So you have two formulas here. So your challenge for the week is knowing which formula to use when, but I promise it's super easy. So your first one is your classic compound interest formula. Let's walk through it. A is going to be the final amount. After I get it compounded, what do I have? Equals P. P is your initial amount with your principal, the initial deposit. I put $1,000 in the bank account when I started, whatever. Times, you've got the quantity of 1 plus, that's always there, 1 plus R. That is going to be your rate, the percentage, written as a decimal, over N. N is going to be the number of times that it's compounded. So in the word problem, it's going to say annually, monthly, quarterly. I've got all kinds of examples for you. And then the exponent here is N. So you're going to use that compound number again times T for time. How much money have we earned over 15 years, over 30 years, so on and so forth. Your second formula is compounded continuously. Now, this is a very popular formula. It's called the PERT formula. I hope you can look at that and see why they'd call it the PERT formula. So in future classes, you might hear a teacher talk about the PERT formula, and that's for compounded continuously. These are easy to identify in our word problems because you are going to see the word continuously. You're going to see the word continuously. That's going to tell you to use the PERT formula. It's set up with still A is the amount when we finish. How much money did I earn? Is equal to P is the principal, the initial amount. E. Let's talk about E really quick. E is a number just like pi. So it represents, you can see here, E represents about 2.718, da, 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 da. So it is a real, it is a number in mathematics, like I said, like pi. On your calculator, you should see an E to the X button to help you evaluate E. Okay, so E is a number. Get it in your head. It's like pi. So E is a number. The rest of our PERT formula, you have raised to the R. That's going to be our rate times time. How many years? Okay, so let's look at this in action. Also on your notes, I do have your common compounded values. So when you see the word yearly, we're going to, for our compound number, the N, we're going to put in 1. When we see semi-annually, that means 2. Quarterly, 4. Monthly, we'll see monthly from time to time. Weekly would be 52 and daily 365. Your most popular are definitely the yearly and monthly. So those will be those will be worded out in our problems, and those will be the numbers we'll use for N in our formula. Okay, you ready? Number 1, Ian invested $13,000 in an account paying an interest rate of 5.7% compounded annually. All good words there. Assuming no deposits or withdrawals are made. There's no changes. How much money to the nearest $10? I'm going to underline that because that phrase does change on your Delta Math problems, how they want it rounded. So to the nearest $10, how much money would be in the account after 12 years? So this is a regular compound problem. I know this because I don't see the word continuously. So I'm going to be using the first formula here. My amount that I'm looking for is going to be equal to my principal. How much did Ian put in the account? $13,000 times 1 plus his rate, the 5.7%, but write it as a decimal, 0.057, all over N. How many times is it compounded? Annually. In my list up here, annually means I'm going to put a 1. Raised to the N again, 1. times T. How many years? 12 years. Okay, so there's all your pieces plugged into your formula. Review that, go back, rewind if you need to. And then we just plug it in our calculator and we evaluate it. So let's head over to the calculator. I'm going to slide the calculator right here so I can see. Here we go. 13,000 times 1 plus, I'm going to give myself a fraction box. Control divide to give you that fraction box of 0.057 over 1. I really didn't need a fraction box now that I look at it. And then 1 times 12. You can put 1 times 12 if you want. I'm going to go ahead and put 12. All right, so we got $25,283.80. I've got it written down here so I can look. $25,283.80. But what did the direction say? To the nearest $10. Remember I underlined that? So at $10 is the 8. I look at the ones or the single dollar mark to tell me that I need to let it rest at 80. So $25,280 is how much Ian is going to earn after 12 years if there's no deposits or withdrawals made, okay? Number 2, Isaiah invested $300 in an account paying an interest rate of 3.7% compounded quarterly. That's an important term. Assuming no deposits or withdrawals are made, how much money to the nearest dollar would be in the account after 16 years? All right. Do you see the word continuously? No. So same formula as before. The amount of money that I'm going to have at the end is equal to 300 was the initial times 1 plus, all right, my rate was 3.7%. Change that to a decimal. All over, how many times was it compounded? Quarterly. Go back up to the list at the top here. Quarterly is 4. Raised to the n, so use the 4 again, times time, 16. So there's all my pieces plugged into my formula. Rewind, refresh if you don't see where I got all those numbers, all right? So now we're going to head to the calculator and we're going to evaluate. Here we go, 300 times 1 plus, I'm going to give myself a fraction box here, 0.0737 divided by 4, all raised to the 4 times 16. I don't know it on top of my head, so we'll just type it like so and enter. $540.81 if I rounded. But I think there was a particular way they wanted us to round, so let's go check it out. 540.806 was our calculator answer. Let's see, to the nearest dollar. I did not underline that before. To the nearest whole single dollar. So the 8 is telling me to round it up. He's going to have $541. There we go. Good job, Isaiah. Number 3, Nolan invested $64,000 in an account paying an interest rate of 3.9% compounded continuously. Red alert, continuously. Assuming no deposits or withdrawals are made, how much money to the nearest $10 would be in the account after 7 years? What did I say? Continuously, red alert. Okay, so that is our compounded continuously formula. That A equals P times E raised to the RT, PERT, the PERT formula. So let's see, the amount we're going to have will be equal to his initial investment, $64,000. E is a number on our calculator raised to the, as my exponent, I've got 0.039 for the 3.9% times 7. You got 2 things being multiplied up there, the rate and the time. So let's head over to the calculator. We definitely need it for this E. All right, ready? Here we go. 64,000. Don't forget any zeros there. E. See my E to the X button by the ln and log and all that good stuff? Hit that. It's going to open up an exponent for us. Thank you, Mr. Calculator. 0.039 times 7. and enter. $84,089.60. What did I say? $84,089.60. But let's see to the nearest $10. So the tens place. So 9 is going to tell me I need to go up. He's going to have $84,090. Who is that? Nolan. Good job. $84,090 in your continuously compounded formula. So you use that PERT formula. If you got anything different, make sure you use the PERT formula. Number 4, Caleb invested $5,300 in an account paying an interest rate of 6.1% compounded monthly. Assuming no withdrawals or deposits are made, how long would it take to the nearest year for the value to reach $13,950? How long? How long? Did you see it? Where'd it go? How long? Question mark. How long? So a week or so ago, we worked with similar problems where we were looking for how long. In these same problems, the time is my exponent again. So we are going to be utilizing the calculator and the insolve function to answer these. Okay, so let's look at it. Do you see the word continuously? No. So this is a regular compound interest problem. So like A equals my initial $5,300. 1 plus, let me erase this, his rate all over compounded monthly would be 12 raised to the n times t. 12 times t is what we're looking for. Now we want after that unknown time for it to equal how much? Right here, the 13,950. So that's going into my A. I want to show y'all this. I want to make sure I'm very clear. We're putting in that for A. I want it to equal that after so many years. We're looking for the years. Let me write my problem. This is our formula. Oh, I missed a 0 there. That would be important. All over 12. Sorry, it's a little messy. And t is my variable. So I'm going to go to the calculator. Calculator, insolve. And I'm going to type in that entire equation. I have an entire equation. I got something equals the rest. I've got an equal sign. I got numbers on both sides. T is my variable. So when I put it in insolve, I'm going to do comma T, and I'll get my answer. Fabulous, right? All right, let's go check it out. All right, had to move my calculator so we can see this problem. We're going to go to menu. What class are you in? Algebra. Numerical solve. Okay, so I got my insolve. I got 13,950 equals, where's my equals? Here it is. It's different than my calculator in my classroom. 5,300 times 1 plus, give me some fraction boxes here, 0.061 all over 12 raised to the 12th t. I'm going to leave it as t so I don't confuse anybody or anything, comma t. Remember, when you use insolve, you're going to write your entire equation. You have to do comma, and you have to tell it what your variable is, or it doesn't know. It's only as smart as the operator. 15.9054. 15.9. Let's see. T equals 15.9054. It's said to the nearest year in my directions. So this 9 obviously is going to tell us scoot it on up to 16 years. Okey-doke. 16 years. It would take 16 years for Caleb, if he invests that much with an interest rate of 6.1% compounded monthly, for it to earn 13,950. Just working backwards a little bit. We're going to do another one. You ready? Number 5. Hudson invested $650 in an account paying an interest rate of 5% compounded continuously. Woo, woo, woo. Red alert, continuously. Assuming no deposits or withdrawals are made. How long to the nearest year for the value of the account to reach $1,220, okay? So continuously, So we are using the compounded continuously formula, PERT formula. Let me go ahead and write that. PERT formula. How long? So we are going to be missing the time. Notice it didn't say how many years. We're looking for the number of years for it to equal 1,220. For it to equal 1,220 goes right there for my A for my final amount. His principal was 650. E is a number. I'm going to use my calculator to evaluate the E. Raised to his rate, 5%. Compounded continuously time. T is my variable. I don't know that. So another star, calculator, InSolve. InSolve. So I'm going to go to my calculator. I'm going to type all of this in, the entire equation, 1,220 equals 650 e to the 500th t, comma, t, right? All right, ready. Menu, algebra class, numerical solve. 1,220 equals 650. E, this E to the X button. Do not do the alphabetical E. Oh my gosh, don't do that. Oh, y'all are going to be emailing me. I don't know what happened. It's giving me an error. I can see it now. Here I can use my numerical T, my variable, or my alphabetical T, comma T. Enter. You should get, if you typed it in correctly, 12.5927. 12.5927. 12.9527. Is that what I said? Let's see, to the nearest year, nearest whole number year, the 9's going to tell me to move it up. 13 years. And there you go. There you have it. So we talked about compound interest. Two formulas, regular compound interest. There's lots of variables going on, but they are going to give you all the information that you need to fill in that formula. Compounded continuously, that one is your PERT formula. You're going to know to use that one when you see the word continuously. It's as simple as that. E is a number. We use our calculator to evaluate E. Use that E to the X button on our calculator. Do not use the alphabet E. That's not going to get you anywhere. Here we go. E is just like pi. It is a number. And there are your problems. So on Delta Math, you've got a mixture of solving compound interest problems. And then you've got a second section that's called solving for time. So that's where you'll need your InSolve to help you solve for that variable. So let me know if you have questions. I'll talk to you later.